Hello everyone. Well, I thought I'll go over this assignment real quick. So the first problem is this diagram, this graph, and well, this question. So how do we figure it out? First, you need to read numbers from this graph. And the idea is that you just get the height of each column here. So the red columns are marginal benefits and the blue columns are marginal cost. And the thing about marginal benefit and marginal cost that you don't read the values exactly at the quantities. You read them kind of in between quantities. Because by definition, marginal benefit, marginal cost is what you're adding to your benefit or cost when adding one extra unit to your production or consumption. So simply put, it means that the numbers need to be put between to make it consistent with what we mean by marginal benefit and marginal cost. So actually it's not showing what we have at each quantity, it's showing how much we add by adding each additional unit. And based on this logic, we're gonna get 10, 9, 8, and so forth and so on over here. So we go from 10 to 3. That's the last one we can read here. Oh, well, in fact, interesting. My bad, we actually don't see anything here. I didn't really add this one. Oh well, so let's get rid of this. Okay, I really need to update this assignment. But anyways, based on, well, I guess you can kind of imply that because the increments were like half a dollar, if we're talking about some measure of value here or cost. So that should be here, right? And this guy needs to be here. I mean, the red. Nope. That should be a 3. So this is how I figured it's 3, because again, it's just increments of 1. And I figured this one to be 4.5 because it's an increment of half. All right, so, and then we use these numbers and these numbers to figure out the rest of the story. So we calculate marginal surplus as the difference between these two values. So 10 minus 1 is 9. 9 minus 1.5 is 7.5, and so on and so forth. Okay, so that's how you get marginal surplus. And then total surplus is the sum of marginal surpluses up to this point. So when you're adding first unit, you have 9 units, $9 of total surplus. Then for 2 units, it's 9 plus 7.5. Then for 3, it's all this put together. And you keep like adding them up all the way. And well, how many units should be produced to achieve allocative efficiency in this case? That's the question. The answer is 6 or 7. So this story has a bit of a twist. It actually doesn't have like a unique number for efficiency, unique quantity for efficiency, because the 7th unit adds exactly as much benefit as cost. It means it's a complete wash. So marginal surplus is 0 for this unit, which means adding 7th unit doesn't really change anything. I mean, it's completely doesn't matter whether you add it or not. So, which means 6 is fine and 7 is just as fine, because again, they both give you exactly the same outcome, especially if you look at total surplus, they're the same. So, interesting again twist. So 6 or 7 is fine. Now, explain your answer by referring to marginal benefit versus marginal cost, marginal surplus, and total surplus. Actually, total surplus, I guess, is the easiest. You just look where you get the largest total surplus, and again, you see that both 6 and 7 are fine. 6 or 7 are fine. So based on this logic, 6 or 7 are efficient quantities. And then marginal benefit versus marginal cost. The 6th unit would be the last one, right, for which MB exceeds MC. The 7th one gives you exactly the same MB as MC, so again it's a wash. So based on this logic, you can go up to 6 and do the right thing, or you can actually add the 7th and it will be just as good. And then in terms of marginal surplus, the idea is to keep going as long as marginal surplus stays positive. And again, that gives you 6. And if you look at 7th unit, because it's exactly 0, adding the 7th unit is not going to change anything. And again, you can also see that it means that total surplus is the same in both cases. So that's how we figure out this part. And then the rest of the story is just understanding where consumer and producer surplus are, and also figuring out deadweight losses if you underproduce or overproduce. So for consumer surplus in this case, if price is $2, then we basically have this price, and then remember consumer surplus is there above the price and below the marginal benefit curve or demand curve, because they are equivalent. And well, you just do your math, right? I hope you know how to do it. So it's height times base. So height in this case is 7 minus 2, right? So this distance, so 7 minus 2, which is 5, times base, which is in this case 10, right? That's 7 minus 2 times, well, 10. Don't forget to divide by 2. So you get 5 times 5, so it's 25. Well, $25, because surpluses are measured in dollars. Now calculate your consumer surplus at $3. So here it is. Now we need to figure out the area of this triangle. So again, height times base divided by 2 gives us what? 7 now minus 3 times, well, 8 divided by 2. So 4 times 4 gives us $16. And then what happens to consumer surplus as the price increases? Well, clearly as you go from 25 to 16, you're going down. Consumer surplus goes down, which makes sense, right? The higher the price, the less surplus consumers are getting. Now, similar story for producers. So producer surplus is there below the price and above the marginal cost or supply curve. So we have two cases here. At $3, when price is here, you just need to calculate the area of this triangle. So it's going to be 3 minus 2, sorry, 3 minus 1, right, this one, times 4, right, this distance, and times 4 divided by 2, so looks like it's 2 times 2, so it's $4. At $5, it's gonna be this side times this side, so it's gonna be 5 minus 1 times 8 and divide by 2, this 8, right? So you're getting 4 times 4, so it's 16. What happens to your produces surplus as the price increases. Well, as we go from $3 to $5, well, clearly producer surplus goes up by 16 minus 4, so $12. Producer surplus goes up by 16 minus 4, so that's $12. Finally, we have this story. Well, again, consumer and producer surplus and total surplus. So I already did it separately. Now you can calculate them on the same diagram. So real quick, if this is the price, then this is the area of this triangle is consumer surplus, right? This area is producer surplus, and put together they give us total surplus. Okay, so I guess I won't spend time on this because it's very similar to what we already did just a minute ago. Well, let's see, maybe I'll do it real quick. So consumer surplus is what? Is 10 minus 7 times, well, 6, right, divided by 2, so it's 3 times 3 is $9, and our producer surplus is 7 minus 1 times, again, 6 divided by 2. Again, it's 7 minus 1. Don't forget about this thing. Don't forget to subtract it. Because if you forget, you will actually get the area of this triangle. Okay, so 7 minus 1 is 6 times 3, so it's 18. And of course, total surplus is just the sum of those two. And it will give us $27. Now, deadweight losses at 4 and at 10 units. So if you're producing less than what is efficient, you will generate some deadweight loss, and that would be this triangle. And you just need to get its area, right? So 8 minus 5 times 6 minus 4, this distance, right? Don't forget to divide by 2, so you get 3 times 2 divided by 2, so it looks like $3. Now deadweight loss at $10, sorry, 10 units. So you draw a vertical line, and now you can see that that will be a deadweight loss in this case. So deadweight loss at 10 is 11, right? Minus 5. This is how you get 5, right? Then times this distance, which is basically the height of this triangle. So 11 minus 5 times 10 minus 6. Don't forget to divide by 2. So it's going to be 6 times 4 divided by 2. So looks like $12 to me. All right, this is how you do it.